Greetings children, welcome back to the biology class. Today we are going to learn the second part of pollination and fertilization. Already in previous class, from the same lesson, I taught you about the definition of pollination, the types of pollination, and I gave you a detailed explanation about self-pollination, which includes the advantages and disadvantages. Now in today's class, we are going to learn in detail about cross-pollination. I guess you remember what I taught you about the definition of cross-pollination. So cross-pollination is transfer of pollen grain from one flower to another flower of another plant of the same species. I repeat the definition. Transfer of pollen grains from anther of one plant to the stigma of another plant of the same species. Okay, so copy down the definition. You have to learn the definition. So this is what the definition of cross-pollination. Cross-pollination occurs within two different plants but of the same species. That's very important. Now in cross-pollination, the other term for cross-pollination is allogamy. I've taught you about that in the last class. Allogamy is otherwise termed as cross-pollination, or cross-pollination is otherwise termed as allogamy. Now, let me teach about the advantages of cross-pollination. So, cross-pollination is comparatively a healthier kind of pollination by which we can develop plants or offsprings or young one are much healthier when compared with self-pollination. You just imagine if there is a plant which is already having a kind of disease, any particular kind of disease. If the plant is producing young one, the disease, if it is a genetical disease or disorder, the young one may also receive the same kind of disorder as it is from the same single parent. But when in case there is two different plants are mixing up to produce another young one, we believe that most probably the young one would be healthier. So this is a first advantage. If you want to get a healthier young one offspring, it's better to have cross-pollination of the particular plant with some other plant. The next kind of advantage is the plant after cross-pollination would generally producing too much of seed. The seed content would be so abundant and the seeds would be very viable. Viable means they can be fertile. They can produce young one very fast. They are not sterile, they are fertile. That is what the word viable means. Viable means they are able to produce young one faster and they have that ability in a very huge amount. So the seeds are abundant and they could produce viable seeds. So these two are the second point of advantage. And what is the third point of advantage is because of this cross-pollination, we could get a sort of hybridized plant. It's not hybridized plant. You know that hybridization has to be there between two different varieties. But when there are two different plants, you can get two different plants, but still they belong to same species, isn't it? So you can get a new variety of plant. It's possible to get a new variety of plant. I hope you remember the 4 o'clock plant. What is 4 o'clock plant? That Mirabilis jalapa, or 4 o'clock plant, that is one which blooms at 4 to 5 o'clock by the evening. So that plant, you would have seen a lot of colors there. There are red color flowers, there are white, there are yellow, there are orange, there are peach colored. So there are so many different colors of these flowers. So if you are doing cross-pollination in those kind of plants like red and white, if you are doing, you can get white flower with red dot or a red flower with white dot, or sometimes you will be getting a pink flower from that particular pollinated plant, cross-pollinated plant. So this is the best example that I could give you. Like new varieties of plant can be obtained by doing cross-pollination. It can be natural cross-pollination or manual cross-pollination, but we could get new variety out of the two different parent plant. It doesn't mean that you will get another plant. You will get the same plant, but as I said with the flower example, you will get a new variety. Okay, that's what exactly this particular advantage mean. And the next one is about the disadvantage. Now, while we talk about the disadvantage, the first disadvantage is pollination is not certain in this kind of cross-pollination. This is purely for natural way of cross-pollination. When some plant is subject to do only cross-pollination, it's not certain, it's not very sure that the plant will get pollinated. Sometimes they may not be getting pollinated. Okay, there is a failure of this thing can happen, right? For example, like papaya. Even papaya, I already told you that papaya is a dioecious plant. There is a female plant and there is a male plant. If there is no chance of a male papaya in that particular area, generally their fruit production, their viable seed production may not be there. Okay, they may produce pseudo fruit, that is false fruit. There is a chance of getting false fruit, but still, when pollination has to occur, when pollination is compulsorily has to occur from cross-pollination, then it's not sure that the plant is getting pollinated. There may be some failure also. There may be some cases of failure too. And the second point is there is more wastage of pollen grain. You have seen that in grass, especially grass is given as a very good example for this more pollen production. Grass is generally will be doing this cross-pollination and they are the one which is producing too much amount of pollen grain. And you would have seen that Parthenium plant, or it's a common wild one which will be producing some irritating sensation or burning sensation on skin sometimes. So these kind of pollen grains, when they are producing too much of pollen, this pollen dust will be roaming everywhere. This pollen dust will be available in this wind current too. So the plant has to produce huge amount of pollen. Just a small amount of pollen would be sufficient for naturally pollination. The other amount, the remaining all the pollen grains would be completely wasted. So this is comparatively the plant, when it is depending on cross-pollination, the plant has to produce huge amount of pollen grain so that about 90 to 95% will get wasted and the remaining 5% will be utilized for the real pollination purpose. Okay, so this is a natural way of adaptation. And then the third important disadvantage is it's actually uneconomical for the plant. Just now I said that when a plant is able to produce when a plant is able to do pollination with just 5% of pollen, what it is exactly producing, then the remaining 95% is actually a waste. Then it is uneconomical for the plant. The plant has to do too much of cell division. The plant has to do too much of nutrient. It has to utilize all the nutrient. It has to supply all the nutrient to produce this much of pollen grain. So this is comparatively uneconomical for the plant. So these are the three major disadvantages. Just recall what are the three advantages. The plants which are produced by cross-pollination would be healthier and they could be able to produce abundant and viable seeds. And there is a chance of getting new varieties by cross-pollination. What are the disadvantages? Pollination is not certain. That means pollination will not occur for sure. It's not a very sure process. It may occur or it may not. Next, the wastage of pollen is so huge and it's comparatively very uneconomical to the plant which is undergoing cross-pollination type. And the next one important topic that we are going to learn is about the adaptation which are being chosen by the plant to do or to carry over cross-pollination, to take over this cross-pollination type. Now, before we get into this concept, you need to know why we are learning about this particular adaptation, why this adaptation is very important. These adaptations are done by the plant. The plant themselves are doing some adaptation so that they can favor, they can support cross-pollination. Where can you see this kind of adaptation? In the plant itself. Okay, so to support cross-pollination, what are all the changes occur in a particular plant to support cross-pollination? That's what generally they used to ask questions from this particular part. So this is, as per our syllabus, this is considered as a very important topic. So the first point, the first topic of adaptation is unisexuality. Unisexuality. Now, unisexuality This is the first word that we are going to learn. The meaning of this word, already in last lesson you would have studied unisexual plants. So unisexuality, which will be completely supporting cross-pollination. That means the plant used to have only either male or female flowers. The plant is compulsorily unisexual so that they naturally support cross-pollination. Now I guess you all are saying the example palm and papaya, right? Almost you all would have said that. So unisexuality is a kind of adaptation which would completely support cross-pollination. There is one more example. There is cucumber. Now you pause the video and turn around and talk to your parents. How many of you are having garden? Just go and check it around if you have a cucumber plant. This cucumber, for the first some 8 to 10 flowers, it would be male flower. Okay, you just go check it by yourself. It's male flower. That means only you can find only the pollen grain. Only the yellow dust would be there just near the flower or inside the flower. From the 10th flower in that plant, from the 10th flower or from after 8th or after 9 or 10 flower, there will be female flowers. Okay, so for each leaf, from the node of each leaf, they will be producing flower. The first 8 flowers of the particular plant would be male. And from 9th flower or from 10th flower, they will be producing female flower. And they will be saying that as, if you have a grandparent at home, you just talk to them, they will be telling you that for some time, the flowers would be like false flowers. That's the word they used to say. They will be saying that as a false flower. That means that flowers will not be producing any fruit. So that you can tell them it's not false flower, they are the male flowers. Okay. So from 8th or 10th flower, they will be producing fruits. That is the female flower, the one which has the ovary, which will be turning into fruit. So this is about unisexuality. And I need to tell you about one more thing, one important secret actually. In papaya, already we have studied that papaya, the plants are very separate. Male and female plants are very separate. But rarely, in some places, you could see papaya as a hermaphrodite plant. Hermaphrodite. Hermaphrodite means a plant which bear both male and female flower in them. So very rarely, some of the papaya would be hermaphrodite, but still they'll be producing male and female flowers separate. Okay. And the next important topic is dichogamy. How to pronounce this? Dichogamy. It's not dichogamy, it is dichogamy. Right? So dichogamy technically or literally means production or maturation at different time. Maturation of what? Gamy stands for union. So maturation of gametes at different time is dichogamy. Maturation of gametes at different time. That is dichogamy. So in a plant, sometimes the androecium, they would be generally bisexual flowers. Okay. So if it is a bisexual flower, they will be producing both androecium and gynoecium. That we all know, right? So when they are producing androecium and gynoecium at the same flower, if they are maturing at the same time, you can't expect them, you can't have a rule for that particular pollen not to fall on the stigma. Naturally, they may fall on the same stigma. So, what is the natural adaptation occur in that particular plant is, if androecium matures first, the stigma will not mature at that time. Stigma would be like so small. So that even if the pollen falls on that stigma, as the stigma is so young, it will not be able to receive the pollen. It will not allow the pollen to grow on it. I guess you could understand that. The anther, if it is maturing first, the gynoecium will mature very late. Okay, so that is the first type. When anther matures first, that particular kind of term is called protandry. I'll tell you the spelling later. Protandry. Okay, protandry. That means androecium matures first. In some plants, the same thing in a reverse manner may happen. Gynoecium would mature first and then androecium will mature. So that is known as protogyny. Okay, I hope you understand this. Now, the third topic is self-sterility. I already taught you about unisexuality and dichogamy. Now, self-sterility means the plant, the pollen, when it falls on the same stigma, will be considered surely as dust. If the pollen grain of the same plant falls on the stigma, will be considered as dust. It will not allow to germinate, or it will not allow to grow further. So that is considered as self-sterility. If the pollen grains get dusted on the stigma of the same plant, that would be considered as a dust particle, not as pollen grain. So this is self-sterility. You can see self-sterility in ray florets of sunflower and also in orchids. So compulsorily these plants would support cross-pollination. Now the next topic is hercogamy. How to pronounce this? Hercogamy. So hercogamy is literally being translated as the mechanical barrier for pollination or mechanical barrier for fusion of gametes. So hercogamy means mechanical barrier which stops the fusion of gametes. So what is this? The pollen grain, when it falls or when it gets matured in a flower, the stigma will naturally have a structure to stop falling of pollen grains onto the same stigma. Either that stigma may have a hooded structure, may have a hood-like structure to stop the entry or the deposition of pollen onto the stigma, or sometimes the pollen grains will face outside the flower so that when they get matured and burst, they will never deposit the pollen grains onto the same stigma. So this is hercogamy. That means the mechanical barrier, which is the technical meaning of the word, mechanical barrier or physical barrier. Okay, so that is hercogamy. You can see this sort of hercogamy arrangement in pansy flowers very commonly, and also in iris flower. We can't see iris in our area, so you can see pansy in our area. So pansy flowers is the very common example. And then the next one is heterostyly. You may know the meaning of the word hetero. Hetero means different. Styly is for the word style. So heterostyly means the length of the style is different from the length of the filament. Right? You know, you can understand what is a style. Right? Style is the middle segment which connects the stigma and the ovary. Isn't it? Now, what is filament? The stalk of the anther. So, if the style is too long, imagine that if the style is too long, then the filament would be so small, so that the anther can never reach the stigma. The pollen can never reach the stigma. In other case, if the style is too small, the filament would be too long. So that when the anther matures and bursts open to release the pollen will never come down where the stigma is. So this is heterostyly. Right? Now I said all these things by words. Shall we see some pictures for all those things? Now this is pansy flower. As I said, you can see that they will be developing some mechanical barrier. Here this is the cross-sectional view so that you can see it very clearly. This is a structure like a hooded structure which is found near the stamen. This is completely stamen. You can see that stamen appendage inside spur. So it would be having too much of spur, so that the stamen, when the pollen is bursting out, it will not be allowing, this spur will not be allowing the stigma to receive the same pollen. And now here you can see the stigma. This is the entrance of the stigma. So the stigma allows the entry of pollen only through one particular way. And you can see one hooded structure. This is hooded style. So naturally, even if some stigma falls on that, the same kind of stigma, the pollen, it will not be entering in. Even if sometimes it enters in, it will not be allowing, the oral style will not be allowing it to germinate through that root. So these are all some mechanical barrier which will be stopping the self-pollination, and by the same kind they will be supporting cross-pollination. The next one, this is the cross-sectional view of oxalis flower. There you can see heterostyly. As I said, heterostyly means the length of the style would be different when compared with the length of the filament. Here you can see the filament length is a little shorter when compared with the length of style. Can you see that? Now, this is primrose. This is evening primrose. So, in this primrose, these are the anther. And here you can see the stigma. The receptive part of stigma would be the top of the stigma, the upper part of the stigma. And these are the anther. When anther matures, it would burst and the pollen grains will fall on the petal. Later by wind current or by any other supportive structures, like maybe by insects or by butterfly or honeybee, it will be passing out from it. It will be taken away from that particular place. So naturally they won't be falling on to the top of stigma which is facing the other direction. So this is another structure. And you can see the length. This is the length of the style and this is the length of the filament. This is too small. In primrose you can see another kind also where the length of filament is too longer when compared with the style length. So you can see two different kind of primrose. Now we are going to revise the terms. So this is protandry. Note down the spelling, protandry. Protandry means in a flower when androecium matures first, that is termed as protandry. And protogyny means when gynoecium matures first than the androecium, or before androecium there is protogyny. Another term is hermaphrodite. We have studied about hermaphrodite in unisexuality. So in hermaphrodite, the word hermaphrodite is an English word. It's not a scientific word. Maybe it's a scientific word, but this is English word only. It's not Latin or something. This is an English word. So this hermaphrodite means an organism which possesses male and female sex organ in a same individual. In animal, you can see that there are so many animals hermaphrodite, but very commonly seen animal, cockroach is a hermaphrodite. Okay, very commonly seen cockroach, there is a hermaphrodite where you can see both male and female in a same individual organism. So today you have studied about the definition of cross-pollination, advantages and disadvantages, and then we learned the different factors by which a plant could naturally support cross-pollination, about these 5 different concepts. So I hope you understood all those things, and I need to give you an instruction today. Today you have to write a test. Today is Tuesday, right? So you have to write a cycle test. From this week onwards, your cycle test, biocycle test will be on every week. So today you have to write a cycle test by evening 8 o'clock. So 8 to 8:25 you will be writing a cycle test, and that's for 10 marks. So there is no change in your question pattern and there is no change in your timing of exam, timing of the test, but you have to write it on every week. That is the only change. You will receive your new cycle test schedule or timetable from your class teacher. And you are supposed to follow the cycle test. You have to take the cycle test seriously. So today by evening 8 o'clock, assemble in front of Google Classroom. You have to switch on your Google Classroom. You have to write the cycle test without fail. So your portion for cycle test is up to cross-pollination. That includes the portion what I taught you the last day. That is pollination and fertilization, completely whatever being taught. So that is your portion for your cycle test. I hope you understand everything. If there is any doubt, ping me back. Thank you, kids. So your homework includes prepare well for your cycle test. That's all your homework. Today's cycle test, you have to prepare very well. Thank you, kids. Stay safe. Stay at home.